Big Data, Data Engineering Services on AWS. Our goal is to understand AWS Big Data Services in this architecture. But before that, let's begin with some basics about data engineering. So what is data engineering? In simple words, making raw data useful. It is the process of designing and building systems to collect, process, and analyze data from multiple sources and formats. So the typical steps for this are to ingest, store, process or transform, analyze, and then visualize data. Here are some AWS services that are used for data engineering. Let's learn more about them. We will start with data ingestion. Kinesis and IoT Core can be used to ingest large volumes of high-velocity streaming data. DMS or Database Migration Service is used to migrate data from one database to another. Snow family of devices are useful for physically transporting extremely large volumes of data via devices. In addition, you can of course use other means like FTP etc. to bring in the data. Storage. S3 can be used to store very large volumes of raw and processed data. Data lake is simply a centralized repository to store structured and unstructured data. On AWS, S3 is used as underlying platform for data lakes. Lake formation can be used to build, manage, and secure data lakes. Redshift is a data warehousing service to store and analyze data using SQL queries. OpenSearch is a search and analytics service suitable for analyzing logs, streaming, and text data. Process or transform data. AWS Glue is a serverless data integration service where you can run your ETL jobs in Apache Spark or Python shell. It also comes with a data catalog and crawlers. Data catalog is a metadata repository of your data. It stores information like location and schema of data. This metadata is stored in its database in the form of tables. Crawlers can crawl data stores and create and update Glue catalog tables. The data sources could be S3 or RDBMS, for example. EMR is a platform for large-scale distributed data processing. It supports big data frameworks like Hadoop and Spark. In addition, you can use Lambda or EC2 for limited or custom processing. On the surface, Glue and EMR seem to have overlapping capabilities. However, let's look at the differences. Glue is primarily used as a serverless ETL service, while EMR is for large-scale data processing. Glue runs jobs on Apache Spark or Python shell, while EMR has a wider range of choices available. Glue provides limited capacity configuration, while EMR has more flexibility on infrastructure choices. Glue logs to CloudWatch automatically, while EMR logs to S3 by default. Analyze. Athena is a serverless analytics service which can query petabytes of data on S3 using SQL. Redshift Spectrum can be used for fast, complex analysis of data on S3 using SQL. Federated queries in Redshift can be used to query and analyze data in operational databases, data warehouses, and data lakes using SQL. With Kinesis Data Analytics, you can perform real-time analytics on streaming data using SQL. Using OpenSearch, you can do log analytics, anomaly detection using machine learning, metrics, and monitoring. While both Athena and Redshift Spectrum can be used to query data on S3, let us look at some of the differences between the two. Athena is a standalone query engine, while Spectrum needs Redshift. In Athena, resources are allocated automatically. It has a truly serverless architecture. While in Redshift Spectrum, you can exercise control over resources. Athena's performance mainly depends on S3 data optimization, while performance of Redshift Spectrum depends on cluster resources and S3 data optimization. Since Athena runs on pooled resources, it can be potentially slow during peak hours, while Redshift Spectrum can provide relatively consistent performance. Athena is suitable for interactive querying, while Redshift Spectrum can be deployed for large complex queries. Visualize. Amazon QuickSight provides intelligent visualizations of your data by reports, graphs, and so on. OpenSearch Dashboard is the visualization tool for OpenSearch data. In addition, you can write your own custom reports or visualizations by fetching process data, for example, from a data lake or a warehouse. Here's a generic architecture depicting how these services can work together. Let's look at some typical use cases to understand this better. A financial services company receives financial data in the form of CSV files from many organizations via FTP every day. The company wants to provide its business analysts an easy way to analyze this data with ad hoc queries. Let's look at the architecture for this use case. We have a data lake with two buckets, raw and processed. Incoming raw CSV files are saved in S3 bucket raw. A glue crawler crawls the raw and processed data buckets to create metadata tables in glue data catalog. A glue job cleans and transforms the raw data to a storage and query efficient format like Parquet and saves it in the processed bucket. Analysts can now run ad hoc queries using Athena against the financial data in the processed bucket. Here's another use case. A large organization has multiple departments with their own IT systems. Sales uses MySQL database, marketing uses Postgres, and there is legacy data in S3. It needs a way to query and analyze data spread across these various data stores. So let's look at one potential architecture for this use case. Here we have three disparate data sources to query, two on different RDBMS and one on S3. We will use federated queries here. Using federated queries, we can query, join, and analyze data across external operational databases, data warehouses, and data lakes. This also allows us to fetch data from external data sources and ingest it directly into Redshift without any complex ETL pipelines. In order to reduce data movement over the network and improve performance, Redshift distributes part of the computation for federated queries directly into the remote databases. The federated query can be used to create a materialized view in Redshift to cache the data until refreshed. Therefore, once the data is available via a query or a view, it can be visualized in QuickSight. Here's a variation of our use case and architecture. Our data source here is in three different RDBMS databases. So here we will aggregate the data in Redshift. For this, we will use DMS or Database Migration Service to replicate data from the source databases into our target Redshift database. Note that DMS can also do ongoing replication to keep the data up to date within Redshift. So once the data is available in Redshift, it can be queried, analyzed, and visualized in QuickSight. Here's another variation of the architecture. Here we bring all our data into S3 data lake using DMS. DMS tasks will have respective RDBMS databases as the source and S3 raw bucket as the target. We can transform and process the raw data using EMR and save it into processed bucket. Now, using Redshift Spectrum, we can query data in S3 and then visualize it in QuickSight. Redshift Spectrum is available only via Redshift. So if you are not already using Redshift, you could alternately use Athena to query S3. Note that since we are loading RDBMS data into S3, you must be cognizant of the following. RDBMS databases often have hundreds of tables with complex relationships between them. Replicating all of the tables in S3 would mean that those relationship definitions and metadata associated with them is lost. Table definition could change in source database and table data will likely too. DMS or any service that is used to replicate data into S3 on a continuous basis would need to handle these scenarios. Alternately, you could selectively replicate data from source database after carefully evaluating your use case. Here's another use case. A large online retailer streams clickstream data in real time from its website and application. We need to analyze this data in near real time, find insights, and also visualize the data. We will be using Kinesis and OpenSearch services here. Clickstream data is ingested into Kinesis data stream, which is then sent to Kinesis Data Analytics, where it can be filtered, transformed, etc. using SQL, and then using Kinesis Firehose, the data is ingested in OpenSearch for further analysis and visualized using OpenSearch dashboard. Now that we have seen some big data architectures, let us quickly review our understanding of data lakes and data warehouses. Data lake and data warehouse play an important role in the big data ecosystem. Let's look at some of the differences. Data lake has raw, unstructured, and structured data, while data warehouse has structured data ready for business reporting. Data lake has schema defined, discovered, post data load, while data warehouse has predetermined schema. Data lakes follow the ELT pattern, extract, load, and transform, while data warehouses follow the ETL pattern, extract, transform, and load. Data lakes have extremely large storage at low cost, while data warehouses have large storage at relatively higher cost. Data scientists, engineers, analysts use data lakes to study and gain deep insights into the data, while managers, business users, analysts use data warehouses for business insights and reporting. Data lakes can be used for predictive analytics, machine learning, business intelligence, analytics, while data warehouses can be used for business intelligence, analytics, reporting, and so on. Here's a summary of service to use case mapping for quick reference. You may pause the video here to review further. With this, we come to the end of our discussion on big data engineering services on AWS.